How AI Sees the World, Understanding Computer Vision. Welcome back to our AI series. In the last episode, we delved into natural language processing, exploring how computers learn to understand and generate human language. Today we're going to take a closer look at another fascinating aspect of AI, computer vision. Computer vision is all about teaching machines to interpret and understand the visual world. It's the technology behind everything from facial recognition on your smartphone to self-driving cars that navigate busy streets. By the end of this episode, you'll have a clear understanding of how computers see and process images, as well as how this technology is being used in our daily lives. What is computer vision? Let's start with a simple question. What is computer vision? At its core, computer vision is a field of artificial intelligence that focuses on enabling computers to interpret and understand visual information from the world, such as images or videos. It's similar to how our brains process and make sense of what we see. Imagine you're looking at a photo of a beach. Instantly, your brain recognizes the sand, the water, the sky, and perhaps even people or animals in the picture. Computer vision aims to give machines this same ability, to recognize objects, understand scenes, and even make decisions based on what they see. How does computer vision work? Computer vision works by breaking down visual information into data that a computer can process. Let's go through the basic steps involved. Image acquisition. The first step is capturing an image. This could be a photo taken with a camera, a frame from a video, or even an image created digitally. The computer receives this image as raw data, essentially a grid of pixels, where each pixel has a color value. Pre-processing. Before the computer can understand the image, it often needs to pre-process the data. This might involve adjusting the brightness, removing noise, like random variations in the image, or resizing the image to a standard size. Feature extraction. Once the image is pre-processed, the computer begins to extract important features. These features could be simple things like edges, corners, and textures, or more complex patterns like shapes and colors. For example, in an image of a car, the computer might first identify the edges of the car, then recognize the shapes of the wheels and windows, and finally combine this information to identify the entire car. Object recognition. After extracting features, the next step is to recognize objects within the image. The computer uses algorithms to match the features it has identified with known objects. For example, it might compare the features of the car in the image with a database of car images to confirm that it's looking at a car. Image classification. In some cases, the goal is not just to recognize individual objects, but to classify the entire image. For instance, if the computer is shown an image of a beach, it might classify the image as beach based on the combination of sand, water, and sky. Interpretation and decision-making. Finally, the computer might need to interpret the scene and make decisions based on what it sees. For example, in a self-driving car, the computer uses computer vision to recognize road signs, detect pedestrians, and navigate traffic. It then decides how to steer, accelerate, or brake based on this visual information. Key techniques in computer vision. Let's explore some of the key techniques and algorithms used in computer vision that make it all possible. 1. Convolutional neural networks, CNNs. Convolutional neural networks, or CNNs, are one of the most important tools in computer vision. CNNs are a type of deep learning model specifically designed to process and analyze visual data. Imagine you're teaching a computer to recognize cats in photos. A CNN works by first detecting small features, like the edges of a cat's ears or the texture of its fur. As the data moves through the layers of the network, the CNN starts to recognize more complex features, like the shape of the cat's face or the position of its body. By the time the data reaches the final layer, the CNN can say with confidence, "This is a cat." CNNs are used in a wide range of applications, from facial recognition to medical imaging, where they help doctors identify tumors in X-rays and MRIs. 2. Image segmentation. Image segmentation is the process of dividing an image into different segments or regions, each of which represents a different object or part of an object. It's like cutting out pieces of a puzzle, where each piece corresponds to a specific area of interest in the image. For example, in an image of a street scene, segmentation might identify different regions for the road, cars, pedestrians, and buildings. This allows the computer to understand not just what objects are in the image, but also where they are and how they relate to each other. Image segmentation is crucial in applications like autonomous driving, where it's important to distinguish between different objects on the road and understand their positions relative to the vehicle. 3. Object detection. Object detection takes things a step further. by not only identifying what objects are in an image, but also locating them. It's like finding Where's Waldo, but the computer does it automatically. For instance, in a security camera feed, object detection algorithms can identify and track people, vehicles, or other objects of interest, even in crowded or complex scenes. The computer draws bounding boxes around the detected objects, making it easy to see what and where each object is. Object detection is widely used in surveillance, where it helps identify potential threats, and in retail, where it can be used to monitor inventory or customer behavior. 4. Facial recognition. Facial recognition is a specialized form of object detection that focuses on identifying human faces. It's the technology behind the facial recognition feature on smartphones, where the phone unlocks when it recognizes the user's face. Facial recognition works by analyzing specific features of the face, such as the distance between the eyes, the shape of the nose, and the contours of the jawline. These features are compared to a database of known faces to identify or verify a person's identity. While facial recognition has many useful applications, such as enhancing security and personalizing user experiences, it also raises important privacy and ethical concerns, which we'll discuss later. 5. Optical character recognition, OCR. Optical character recognition, or OCR, is a technique that allows computers to read and interpret text from images. It's used in everything from scanning documents to reading license plates. Imagine you have a scanned document, and you want to convert it into editable text. OCR software analyzes the shapes of the characters in the image and matches them to the corresponding letters or numbers. Once the text is recognized, it can be edited, searched, or used in other digital applications. OCR is widely used in digitizing printed materials, such as books and invoices, making it easier to store, search, and share information. Applications of computer vision. Computer vision is transforming many industries and aspects of our daily lives. Let's look at some of the most impactful applications. 1. Healthcare. In healthcare, computer vision is revolutionizing the way medical images are analyzed. For example, CNNs are used to detect tumors in X-rays and MRIs with incredible accuracy. These algorithms can spot patterns that might be missed by the human eye, leading to earlier and more accurate diagnoses. Computer vision is also used in robotic surgery, where it helps guide surgical instruments with precision. This technology allows surgeons to perform minimally invasive procedures with greater accuracy, reducing recovery times for patients. 2. Autonomous vehicles. Self-driving cars rely heavily on computer vision to navigate roads, recognize traffic signs, and avoid obstacles. Cameras mounted on the vehicle capture real-time images of the surroundings, which are then processed by computer vision algorithms to understand the environment. For example, the car might use object detection to identify other vehicles on the road and predict their movements. It might also use image segmentation to distinguish between the road, sidewalks, and other elements of the scene. This information is then used to make decisions about steering, acceleration, and braking. 3. Retail and e-commerce. In retail, computer vision is being used to enhance the shopping experience and improve inventory management. For example, some stores use computer vision to track customer movements and analyze their shopping patterns. This data can be used to optimize store layouts and product placements. E-commerce platforms also use computer vision for visual search, where customers can upload a photo of an item, and the platform finds similar products available for purchase. This technology makes online shopping more intuitive and personalized. 4. Security and surveillance. Computer vision is widely used in security and surveillance to monitor public spaces, detect suspicious activities, and enhance safety. For example, object detection algorithms can identify and track people in crowded areas, alerting security personnel to potential threats. Facial recognition is also used in security, where it helps identify individuals of interest or verify identities at access points. However, the use of facial recognition in surveillance has sparked debates about privacy and civil liberties, which we'll discuss later. 5. Agriculture. In agriculture, computer vision is used to monitor crop health, optimize irrigation, and even automate harvesting. For example, drones equipped with cameras can capture images of large fields, which are then analyzed to detect signs of disease or pest infestations. Farmers can use this information to make more informed decisions about crop management, leading to higher yields and more efficient use of resources. Computer vision is also used in automated systems that can sort and grade produce, ensuring that only the best quality products reach consumers. Challenges in computer vision. While computer vision has made significant advancements, it also faces several challenges that need to be addressed. 1. Variability in images. One of the biggest challenges in computer vision is dealing with variability in images. Objects can appear differently depending on lighting, angle, distance, and background. For example, a car might look different in a sunny environment compared to a cloudy one, or when viewed from the side versus the front. Computer vision algorithms need to be robust enough to recognize objects under various conditions. This requires training on large and diverse datasets, as well as using advanced techniques like data augmentation to simulate different scenarios. 2. Real-time processing. Another challenge is the need for real-time processing, especially in applications like autonomous driving or surveillance. Processing images quickly and accurately is crucial for making split-second decisions, such as avoiding an obstacle or identifying a security threat. Real-time processing requires powerful hardware and optimized algorithms that can handle large amounts of data at high speeds. This is an area of ongoing research and development in computer vision. 3. Privacy and ethical concerns. As computer vision becomes more prevalent, it raises important privacy and ethical concerns. For example, facial recognition technology can be used to track individuals without their consent, leading to potential abuses of power and violations of privacy. There are also concerns about bias in computer vision algorithms. If the training data is not diverse enough, the algorithms might perform poorly on certain groups of people or in specific situations, leading to unfair outcomes. Addressing these challenges requires careful consideration of the ethical implications of computer vision technology, as well as the development of guidelines and regulations to ensure its responsible use. The future of computer vision. The future of computer vision is incredibly exciting, with advancements that will make machines even better at understanding and interacting with the visual world. 1. Enhanced object recognition. We can expect to see continued improvements in object recognition, with algorithms becoming more accurate and capable of recognizing a wider range of objects in more complex environments. This will open up new possibilities for applications in areas like robotics, augmented reality, and beyond. 2. AI-powered creativity. Computer vision is also playing a role in the creative industries, where AI is being used to generate art, music, and even fashion designs. In the future, we might see AI collaborating with human artists to create entirely new forms of expression, blending human creativity with machine precision. 3. Integration with other technologies. The integration of computer vision with other technologies, such as NLP and robotics, will lead to more intelligent and capable systems. For example, combining computer vision with NLP could enable machines to not only see and recognize objects, but also understand and describe what they see in natural language. 4. Ethical AI. As computer vision technology advances, there will be a growing focus on developing ethical AI systems that respect privacy, avoid bias, and are used responsibly. This will involve ongoing collaboration between technologists, ethicists, and policymakers to ensure that the benefits of computer vision are realized while minimizing potential harms. Conclusion. In this episode, we've explored the fascinating world of computer vision, from its basic principles to its real-world applications and future potential. We've seen how machines are learning to see and interpret the visual world, and how this technology is transforming industries from healthcare to agriculture. In the next episode, we'll dive into another important area of AI, robotics. We'll explore how AI is being used to create intelligent robots that can perform tasks autonomously, from manufacturing to exploring outer space. Thank you for joining us on this journey through computer vision. Don't forget to subscribe and hit the notification bell to stay updated with our AI series. See you in the next episode.